Welcome to lesson 2, which is chapter 8.2a. Today we're going to talk about trigonometry on the coordinate plane. Now, this is going to combine some of the trigonometry stuff that you guys learned a little bit earlier on in Integrated Math 2 lessons and some coordinate plane, meaning x, y axes. So it's going to combine a couple ideas, and it should be pretty new in most regards for a lot of people. So let's go ahead and dive on in. All right, so the first thing is we're going to draw angles in something called standard position. We're going to be able to find something called a coterminal angle. And then we're going to talk about degree measures. This radians thing we'll talk about in a little bit later of a section. All right, so let's talk about the parts of an angle. Now, there's some different parts of an angle than you might have seen before. When we have an angle, most of our angles are referred to by a single letter, angle A or something like that. But you can refer to angles by 3 letters, where the vertex, we'll talk about that, is the center letter, and the other 2 letters are points on the sides. An angle consists of 2 different rays going off in different directions. So this is angle A or BAC or CAB. The turnaround point is called the vertex. Where it opens up is the angle, and we usually use the symbol theta to represent the angle. So theta represents an angle. It's just like a variable x or something like that. And then these are some new words over here. We have this side right here might be referred to as the initial side. And then the angle opens up, and where the angle ends is referred to as the terminal side. So the initial side is kind of our starting spot, and then it opens up kind of like a hinge or a book, and the other side is called the terminal side. So a little bit of vocab there for us. All right, let's talk about standard position. So the standard position of an angle is when we put an angle in such a way so that way the initial side is on the positive x-axis. All right, so this is the initial side of our angle. It's on the positive x-axis, which basically means it points to the right. The vertex is at 0, 0. And then what happens is the terminal side kind of spins around in a circle, and it can spin around as much as it wants. Wherever the terminal side ends is where we say the angle lies. So we might say the angle lies in a certain quadrant or something like that, and that's because that's where the terminal side is. So right here, we just have this point P. P is just any point on the terminal side. So a lot of times we'll define our angles based on a point that's on the terminal side. So this point could be something like -4, 5 or something like that. And that's a point on the terminal side. Now, when we talk about the quadrants, each of the quadrants has a name. And this might not be something you're super familiar with, but it's something you should know. Quadrant in the top right is quadrant 1, and then we go counterclockwise. So quadrant 2 is the top left, quadrant 3 is the bottom left, quadrant 4 is the bottom right. Each quadrant is broken into 90 degrees. So quadrant 1 is 0 to 90, quadrant 2 is 90 to 180, quadrant 3 is 180 to 270, and quadrant 4 is 270 to 360. And then we repeat the quadrants. The angles can keep going. We can go above 360 degrees and just keep wrapping around like a clock, around and around in a circle. But we still repeat the quadrants, 1, 2, 3, 4. And so knowing those angles or those quadrants is going to be really important. Being able to describe where an angle exists is one of these first new skills. All right, and then just one last little bit of review stuff. This is something you should have seen before. This is our right triangle trig. If we have a right triangle, if we can draw a right triangle, then we can do SOHCAHTOA, where the sine of an angle is equal to the opposite over the hypotenuse. The cosine of an angle is a ratio of the adjacent over the hypotenuse, and the tangent of an angle is the opposite over the adjacent. So this is something you should have seen before back in geometry. Let me reiterate that one more time. The sine of a given angle is the opposite side over the hypotenuse side. The cosine of a given angle is the adjacent side over the hypotenuse side. And the tangent of a given angle is the opposite over adjacent. So the sine, cosine, and tangent are these ratios that are made up by taking these sides and making fractions of them. Okay, so that's something we should have seen before. Let's go ahead, let's practice that real quick, make sure everyone kind of is familiar with that. So if I have angle S, let's highlight angle S real quick. Angle S is this angle over here. That's where our theta is. We could do the sine, cosine, and tangent of that angle. So we could say the sine of angle S is equal to, we said the opposite over hypotenuse for sine. So opposite of S is 5. And then the hypotenuse is the one across from the 90. So that's 5 over 13. Then we can do cosine. Cosine of angle S. We said cosine is the adjacent. Adjacent means that the side next to it, that's not a hypotenuse. So next to it is 12 over hypotenuse 13. So that's 12 over 13. And then we could do tangent of angle S. The tangent of angle S is going to be the opposite side, which we already said was 5, over the adjacent side, which we said was 12. So we get 5 over 12. Okay, so that's a little bit of trig, right triangle trig, a little bit of review there of how to do sine, cosine, and tangent. Now, a moment ago, you might have heard me refer to it as SOHCAHTOA. SOHCAHTOA is just an acronym to help you remember the order for the 3 trig functions. The sine of an angle is the opposite over hypotenuse. The cosine of an angle is the adjacent over the hypotenuse. The tangent of an angle is the opposite over adjacent. We say SO, sine opposite hypotenuse, CA, cosine adjacent hypotenuse, TOA, tangent opposite adjacent. So it's just a helpful way to help you memorize which trig functions get which side lengths. This is something you should have seen before in a previous math class, and hopefully it seems fairly familiar to you. All right, so let's talk about what is trigonometry. So the mathematics of dealing with the relationships of the sides of an angle and creating a triangle and then the relevant trig functions for any angle possible is what trigonometry is. So given any angle and standard position, we can create a right triangle by extending a vertical line. So it's always a vertical line to the from the terminal side to the y-axis. So if this green angle right here is my angle, I can make a right triangle by dropping down a vertical line. No matter where my terminal side is, I can always drop down a line or draw up a line to make a right triangle. The 90-degree angle of your right triangle this chapter should always be on the x-axis. Your 90-degree angle should never be touching the y-axis. It should always be on the x-axis. Well, so here's what we're going to do. We are used to doing trigonometry with opposite adjacent hypotenuse, but since we're now on a graph, we're going to use some different letters. Our opposite side is always going to be up-down movement. So we're going to say our opposite side is a y value. Our adjacent side is always going to be left-right movement. So we're going to treat that as an x value. So opposite is now a y value, adjacent is now an x value, and our hypotenuse is going to be called r. The reason we call it r is because if you think about this thing going around in a circle, the r would be the radius of that circle. Okay, so that's what r stands for, is for radius. So the opposite side is a y value, the adjacent side is the x value, and then the hypotenuse is the r value. Well, x and y, that gives us a point, and that's always going to be a point on the terminal side. And if we want to find the r value, the hypotenuse, well, this is a right triangle, so we just have to do Pythagorean theorem. So this is just kind of a modified version of Pythagorean theorem, and it says that the r value, the hypotenuse length, is equal to the square root of the other two sides squared and added together. That's just our Pythagorean theorem, right? So this is a little bit different than the trig we've done before. We're going to kind of refer to things a little bit differently. So in the previous slide, I had said that the sine of an angle was the opposite over the hypotenuse. But if I translate it now, I'm going to say the sine of an angle is my y value over my r value. All right, so opposite is y, hypotenuse is r, adjacent is x. Otherwise, we can use it all the same way as before. Okay, so you'll see that here. So our sine of an angle is now the y value over the r value rather than the opposite over hypotenuse. The cosine of an angle is the x over the r, so the adjacent over the hypotenuse. And the tangent is y over the x, or opposite over adjacent. So our y is really just our opposite. Our x is really just our adjacent. And our r is really just our hypotenuse. So it's really just using the same trig functions. Nothing's really crazy different. It's just we're going to use these different letters now because we're on the coordinate plane and we have these x and y values that we can use. Don't forget, if you're trying to find the r value, you can use this formula, but really this is just a modification of Pythagorean's theorem. So a lot of times you'll hear me just refer to it as Pythagorean's theorem. All right, so let's go ahead and try what a problem is going to look like on the homework for this section. So it says, given the point 12, -5 is on the terminal side of an angle, draw an angle theta and find the three trig functions. Well, all right, so we got to draw our angles. So what you're going to do is you're going to draw an xy axis, and then what you're going to do is plot a point 12, -5. So 12, -5, I'm going to go to the right 12 and down 5. This doesn't have to be to scale in any way, but I'm going to put a point right there. And what I'm going to do is I'm going to draw a line from the origin to this point. Okay, this is my angle. I'm going to change the color a little bit, so I'm going to draw it over in green. This is the terminal side of my angle. And then I'm going to draw the initial side over here on the x-axis. So this is my angle in standard position. To get here, what happened is the angle opened up like this. It went to there. I don't necessarily need to draw that piece in, so I will go ahead and erase it for now. And what I'm going to do instead is I'm going to label that point that I drew. I'm going to label it as 12, -5. Okay, because what's going to happen is I'm going to have to make a right triangle here. So to make my right triangle, I'm going to extend this line back to the x-axis, and everyone hopefully can see this right triangle that just got made. The x value, the left-right movement here, is 12, and the y movement, the up-down movement, is -5. Now I need to do a little bit of math to get the r value, so I'm going to say my r value is equal to the square root of 12 squared plus, don't forget parentheses, -5 squared. So that's r equals the square root of 144 plus 25. So r equals the square root of 169, which means our hypotenuse is 13. Now x and y, so your left and right and your up and down, can be positive or negative. Right positive, left negative, up positive, down negative. But the r value is always positive. So our hypotenuse here is 13, our r value. Okay, that's great. We've labeled our triangle. We should be good to go now. The last piece here was we had to find the three trig functions. So we need to find the sine of our angle, we'll call it theta, the cosine of our angle theta, and the tangent of our angle theta. Well, we've said that the sine, cosine, and tangent are just opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. We've also changed those now to be in terms of these new values. So sine, it's my opposite over my hypotenuse, or my y over my r. So that's -5 over 13. The cosine of my angle is my adjacent over hypotenuse, or my x over my r. So that's 12 over 13. And the tangent of my angle is my opposite over my adjacent, or my y over my x. So that's -5 over 12. So there we go. We found our three trig functions for this right triangle we made. We drew the right triangle by plotting a point and then turning it into a right triangle. That 90-degree angle, remember, is always going to sit on the x-axis. Then we found our hypotenuse using Pythagorean's theorem. And then lastly, we just did our SOHCAHTOA to get our trig piece here. All right, one last thing that you guys will learn to notice as you're doing these problems, and one thing you should check as you do these problems, is that in different quadrants, different trig functions are positive and negative. So what you should have seen in that last example was our triangle is over here in quadrant 4. So our sine value was a negative number, our cosine was a positive, and our tangent was a negative. Because in quadrant 4, only cosine is positive. And the reason only cosine is positive is because here our y value is negative. Tangent and sine both use a y value, so they are negative here. But cosine only uses an x value and an r, so it's positive. R is always positive, so it really just depends on what x and y are to see what other things are positive. In quadrant 1, x and y are both positive, and r is always positive, so both things are positive. In quadrant 2, x is now negative, so anything with an x, meaning cosine and tangent, are now negative. In quadrant 3, x and y are both negative, so both sine and cosine are negative, but tangent is now positive because it's x and y, so a negative negative becomes a positive. And then lastly, to repeat, in quadrant 4, x is now positive, so cosine is positive, but tangent is now negative. So I'm referring back to this idea that we can say sine is r of an angle is our y over r value. Cosine of an angle is x over an r value. And tangent of an angle is our y over our x value. So based on that information, we know that since r is always positive, it just depends on whether y or x or both are negative to determine when things are negative. So here's how it works. In quadrant 1, everything is positive. And so sine is positive, any sine angle is positive, cosine is positive, and tangent is positive. Everything is positive. Okay, in quadrant 2, only sine is positive. Everything else, cosine and tangent, are negative. In quadrant 3, now sine is negative and cosine are negative, but tangent is positive because it's a double negative at that case. And then in quadrant 4, we now have a sine being negative, cosine is positive, but tangent is negative again. So here is a helpful way to memorize this. Okay, so you don't have to just memorize these things straight up. There's a nice helpful way to memorize this, and it's an acronym. It goes all students take calculus. Silly acronym, but it's how I memorize it. You can use any sort of acronym you want. Make up your own. Make it fun. Make it silly. I don't care. All students take calculus. The first letter tells us what's where. Quadrant 1, A for all are positive. S in quadrant 2 means sine is positive. Everything else is negative. T means tangent. Everything else is negative. And C means cosine is positive. Everything else is negative. If you can memorize this, it'll help you check your answers. It'll help you see that based on what quadrant you're in, you can really help pay attention to what's positive and what's negative. All right, so one last problem. It says, given the point square root 5, 2 on the terminal side of an angle, draw the angle, find the three trig functions, just like we did before. Let's go ahead and give it a try. So we'll draw an angle. 5, root 5, 2, those are both positive. So we'll go to the right root 5 and up 2, and that's how we'll get to our point. So our x value is root 5, our y value is 2. We could draw our 90-degree angle right there. We need to find our hypotenuse. Okay, actually, I'm going to highlight my angle in green because I like the way that looked last time. So there we go, that's our angle. We need to find our hypotenuse here, so let's go ahead and do that. We're going to use our modified Pythagorean theorem, so we're going to say r equals the square root of the square root of 5 squared plus 2 squared. So that says r equals the square root of 5 plus 4, so r equals the square root of 9. So r equals 3. So our hypotenuse here is 3. We did that. We simplified that. That's great. R is always positive. Don't forget that. We're in quadrant 1. So what we should remember from just a second ago is the acronym ASTC. Since our angle's in quadrant 1, all 3 trig functions that we find should be positive. All right, let's go ahead and try it. So we're going to say the sine of this angle. Oops, I didn't draw my angle in. There's my angle. The sine of this angle is equal to the opposite over the hypotenuse. My opposite is 2, or my y value is 2, over my hypotenuse. My r value is 3. The cosine of this angle is my adjacent, my x value, over my hypotenuse, my r value. And then the tangent of this angle is my opposite over my adjacent, or my y value over my x value. So that's 2 over root 5. Now, normally when we have a radical on bottom, we have to rationalize the denominator. But for these problems, we're not going to worry about it for now. At a higher level, they may ask you to do that. But for now, we're just going to leave it unrationalized. So we get 2 over root 5 for our tangent. So we have sine equals 2 over 3. We have cosine equals root 5 over 3. And we have tangent equals 2 over root 5. Optionally, if you want to rationalize, you can. It doesn't matter. So you could have written 2 root 5 over 5. That's totally acceptable as well. Notice all 3 trig functions are positive because this one, y over r, this one, x over r, this one, y over x, everything is positive, so all those things were positive. All right, that should be enough information to get you started. You should be able to try the homework a little bit. Ask questions. Please come to pause before class if you want some extra help, or after you're done with class. Doesn't matter. If you have any questions, please reach out. This stuff will get really confusing really fast if you don't try and understand the basics to the best of your ability. Okay, I'll see you guys in our next live session. And until then, I hope you have a great day.